Welcome back to DipanshVideoTime. This is the first video of a FPS game series. At the end of the FPS game series, we'll have a game similar to the one I'm going to be showing right now. Just watch the screen carefully. So as you can see, this is the game. Wait a little bit. So it'll take some time to load the game obviously. Just wait a little bit. So you can see that you can shoot the enemies. So you can just shoot it like that. And now at the start of at the end of this video, we will have something like this. So as you can see, this will just be a simple floor raycasting, and then you can see that will have this nice background at the end. So yeah, let's get started and make this much in this video. So let's go back to our game and first import Pygame. Now after importing Pygame, we would want to import another and that will be NumPy. So let's just import NumPy. Yeah. Then after that, we would want to import from NUMBD, I think. No, number, import ng. So after we have imported everything, let's first create the main function. So let's just wait a little bit. So what we want to do first is define main. So define main, and inside that we'll put pygame.init. So instead of pygame, let's put it pygame as pg. So pg dot init. Then after that, the second thing we want to do is screen is equal to pg dot display dot set underscore mode 800 by 600. So put this in a parentheses like this and like that. Then after that, the second thing you would want is to make running equal true. So running is equal to true. Then second after that is clock is equal to pg dot sign dot clock. So let me just make the code a little bit more here. And yeah, that's it. Then after that, we can put our horizontal resolution HRES to be 120. So let's just put horizontal resolution, and then after that we can type half vres to be equal to 2, not 2, like 100, and let's call it half of our vertical resolution, because we'll be looking at the center. We don't want to be looking at the top of our game. We want to be looking at the center so we can equally position our enemies, our floor, and our walls at the correct position. Even our gun with the hand I showed you earlier. Then after that, we can put our mod to equal to HRES by 6, which would be 2. And after that, pause X and pause Y and what would be equal to 0, 0, and 0. So pause X 0, pause Y 0, rot 0. Yeah. Then after that, frame is equal to np.random. So import implies np. So np.random dot uniform, and we want to uniform it as 0, 1, then after that hres, then half of vres times it by 2, then 3. Like that. That will be our frame. But then after that, after we have our frame ready, the next thing we want to do is sky to be equal to pg dot image dot load to the skybox2 dot jpg, if I'm correct. So skybox2 dot jpg is something like this. Let me just zoom in, so it will be kind of blurry, and I want kind of a blurry scene for our game. So the map we are looking at will be perfect because when we add the buildings, this would be much more better. So skybox2.jpg. Then after that, our sky again should be pg.servearray.array3d, and that's how we are going to be doing it 3D without any Ursina, or yeah, mostly Ursina is the only thing that does it, right? No, or SQL 3D. We are not using it. That's why we're using NumPy, because then we can create a 3D array. Then that array will be our level. So then we can identify each variable to one like number. We can just write out our tiny level over here, around 5 lines. Then after that, done. We have our tiny map or something. So that's why we are adding a 3D array. So then we can just type tab. So we have our sky. Now floor is equal to, and yeah. After the array 3D, sorry, I forgot something. It will be pg.transform.scale sky. Then after that, 360 and half of vres, half of vres times 2, like we did before. Yeah, like over here. Then after that, after we do that, after all of these 3 brackets, all we need to do is divide by 255. Now remember, I'm using very good numbers because the number needs to be correct if you want the result we got earlier. Next, after that, you can put floor. So floor is equal to pg dot serve array dot array3d and pg dot image dot load to be floor dot jpg Sorry about that, my headphone is always falling off. And then after that, divided by 255. And that would be correct. Okay, so now after that, we'll need to do something else. So inside the main function, type while running. Now that's why on the top we said running to true. So in my previous videos, if you didn't know, I told you that this variable can help us get more control over our main loop. So while running for event in pg.event.get, what we want to do is most likely to if event.type would be equal to pg.quit, or event.type would be equal to equal to pg dot key down, and event dot key is equal to pg dot escape, and escape, yeah. Then what we would want to do, so event dot key and event dot type. Then what we would want to do is running is equal to false, and then after that, so after we do all of that, so we can just check it one time. Key down and event dot key is equal to pg dot k escape. Running would be equal to false, and then right after that, what else would we need? Not that much, I think. Yeah. So we can just go down. So over here, all we need to be type is going to be something quite long. Okay. So please bear with me. Frame is equal to new frame, new underscore frame, and that new underscore frame will be a function that we're going to be making later. So new frame pause x or y, and then after that rot, and after rot frame, then sky, then floor, then x-res, then half of v-res, then after that, and lastly mod. Oh my god, why is it always falling down? Just wait a second. Yeah. Okay. Now the next thing that we will want is our surface. So the next thing we would like to type is surf is equal to pg.surfArray. So pg.surfArray would be technically make underscore surface, which would again, I think, be something that we're going to be adding later. And sorry, I did something wrong. That should be make surface like that, and then frame times 255, and then after that surf dot pg dot transform. So surf is equal to pg dot transform dot scale our surf, and then our 800 to 600, which is most likely the one we put up here. Right, that's correct. And then FPS, so frames per second, or first person shooter, is equal to int clock dot get FPS. Then after that, pg dot display dot set underscore caption, and I'm just gonna type in FPS game part 1 plus. Now, yeah, let's just add this. So FPS game part 1. So first person shooter game part 1. Then after that, screen dot blitz surf and 00. So we are going to be blitzing this. So pg dot transform. That's good. Okay, that's good. Weird. It should be actually showing transform dot scale. Yeah, I have no idea what happened over here. It wasn't showing the function that we use a lot of times. That must be just a tiny error of VS Code. And then at the end, pg dot display dot update. And then let's just type in pause X, pause Y, and rot, I think. Yeah, rot would be equal to movement, which is going to be actually what we're going to be creating right now. Pause X, pause X, pause Y, rot, pg dot key underscore rest. That's correct. pg dot key dot key underscore press dot get underscore press. Sorry, I'm making all of mistakes. And then right after that, clock dot. And now after we have that, we can just go back over here and say that you want to make define movement. Pause X, pause Y, rot, keys, and ET. And yeah, you can see that it is now going to be working. So the first thing we want to do is if keys, and which is going to be the one that pg dot k underscore left, or keys or a rot is equal to rot minus 0.001 times, sorry, times around et. If I do my code, let me just check my code one time. Yeah, et. Then after I do et, we can just copy this whole thing, make it for k underscore right, and rot would be, instead of rot minus, rot plus, and this would be, I think, DADWS. Yeah. D. Then after that, we can just copy it like that on the screen, and then we would be having something like up and then down. Up and down will be a little different. We're not going to be rotating our screen anymore, but instead we're going to be changing our positions. So pause X, pause Y, and nothing else would be equal to, so pause X and pause Y would be this time now equal to pause X plus NP dot cos of rot and then times it by 0.002 times S, and then after that it would be cos Y plus NP dot sin of rot times then the dot sin of rot times 0.002 times it by it. And then after that, we would have the way for going forward. And obviously, this would be forward. And for down, you can just copy it, paste it. And let me just check if I put everything correct. Everything is correct. So then after that, the next thing that we would want is for down. So down would be kind of like just the same thing, but you're just going to be minusing it. So minus, minus S. And we have our whole movement done. The only thing we need to do is return our pause X, pause Y, and rotation. So that next time our movement would be, we'll do that, pause X and pause Y. Yeah, here. It will be like this. So now, for the last bit of code, it's going to be not a lot, I would say, but yeah, it's gonna be quite a lot. Okay, so just bear with me, and in the under the next 10 minutes, you would have a fully functionable way to go around 3D places. Okay, so all you need to do is I'm gonna go through this quickly. So type at the rate NJIT. Okay, and this is going to be what's going to help us very much. Instead of writing a more 100 lines of code, this will reduce it to only 10 lines of code. So new frame is bearing. So new frame is pause X, pause Y, rotation, the frame, the sky, the floor obviously. Then after that we're going to be having the resolution, half of VRes, and then mod. And then right after that, all you need to do is type in for I in range href. What I'm going to be doing is sin cos and cos2 would be equal to np dot sin of rot I, rot underscore I. Now this is going to not gonna work for reason because for I in range at resolution it should be on top. We have to put rot I is equal to rot plus np dot sin or something. No, not sin, but just we're going to use dg2rad. Yeah, I'm using a lot of mathematical formulas here. Dot slash mod equals, and then we're going to be minusing it by 30. So we're going to be having the, is this correct? Yes, that's true. Then after that, in our rot I, so if you come back to rot I again, you can now see that it's working. So then after that, np dot cause rot I, then after that, np dot cause, goodness, this is a lot actually. Np dot big rad, back to rad, like we did before, and then that would be I with I slash mod. Am I correct? Yes. I slash mod minus 30. So if we check it, if it's correct, we have it to be equal to np.sin rot I to np.cause rot I, then to np.cause np.dig2rad I slash mod 30 minus 30. And now we only have around, let's say, yeah, 10 more lines. So all you have to do is frame I, and then after that, colon. So frame I and colon. Just wait, okay? I know you'll be thinking why. I'm going to explain it again. So sky, so would be equal to sky, goodness, okay, in np dot red to dot, the rat to dig. But this time, instead of dig to rat, we are doing rat to dig. So that means that degrees to radius. And then after that, radius to degrees. If I'm correct, that should be it. And then after that, all we need to do is np.rat to dig. We're going to be adding rot underscore I. Yes. Then, where's the, is this button? Yeah. No, sorry. Percentage of 359, and then all the way at the end we would want another column, and you can see that there's kind of no errors. That means we're actually doing very good for now. So for j in range, half the resolution, and what we want to do in f in j in range, half vertical resolution, n is equal to half the res, uh, half the res again. So all like that, and yeah, so like that, and half the res by half the res, something over here, then over here, then half the res minus j, which is the one at the top. Goodness, I'm getting kind of close to. I'm trying to remember all the mathematical formulas. So x and y, which is the two positions, cos x would be added. Sorry about that. Xy, then cos x will be added, and added cos times n, and then cos y would be added, then added to sin times n. Okay, and now instead of x and y, now we are going to have x and y. Okay, and that would be equal to integer of x times, remember, 2 percentage of 1, and then after that times it by 99. Then to that we were going to be adding to the integer of y times 2 modulus, not modulus, like percentage of 1, then times it by another 99. So instead of x and x, now we're going to be x and y, then both would be times it by 99. And now we're almost done with the whole game. What you have to do is shade it. Shade is going to be equal to 0.2 plus 0.8 times, and what we're going to do is 1 minus j by half of the resolution. Now after that, after we have the shade all complete, frame is equal to frame and I, and then after that half of the res, and then from that we're going to be timesing it by 2, and after we times it by 2, we want to minus it by j, minus it by 1, and I'm just gonna control X and control V for here, and this was going to be equal to shade times floor, and then XX and YY over here, and then yeah, we're kind of done. All we have to do is at the end return frame, so return frame like that, and then sorry about that. Now we have to the last 2 lines of code. Actually, if I'm gonna be practically correct, the last 3 lines of code. So the last 3 lines of code is if, so if name is equal to main, then main and pj dot white. Now if we run this, let's see if it's working or not, because after a long time of coding, a successful game always helps remind. Now as you can see that at the start we are left with this kind of screen. So let's find out why. So we have all of our degrees and radiation. So new frames, we're importing everything. And at res, rot I would be rot plus np dot dig to rad I slash mod minus 30. And then sin cos 2 np dot sin rot I to np cos rot I to np cos np dot regret to I mod. Then after that, frame 1 sky int np. Okay, so sky int np dot rat to deg rot I 359. That then after for j inside. I'm also checking all the spacing and everything. So I found out one error. I accidentally placed this over here. And now, is there any difference? And there we go. We have this practically generated scene. And now this is the first part of the video series. In the next part, we are going to be adding like some walls to the maze. So like, it looks like a maze. Then so we're going to be adding sprites and then much more. But for now, this is how much we have. So I hope you like the tutorial. Please like, subscribe. Until next time, Dipansh video time is now, don't forget that the assets are in the description below. You have to go to the GitHub page and download it. So, thank you for everything, and I wish you good luck. And there will be a full series coming on, and I'm also going to be compressing the whole series into one video so that you can watch it in far less time and not wait. So, bye. See you in the next video, and peace out.